Hello guys, in this video we will see vectors, linearly independent and dependent vector. So suppose we have given the three vector in R3, which is 1 1 minus 3, second vector is minus 1 1 minus 1, and third vector is minus 1 minus 1 3. These are the vector from vector space R3, which is from vector space over R. Now we will check that these three vectors are linearly dependent or independent. So we know that a method we will form a matrix using by writing these vectors in column wise and form a matrix, which are here. We can see this, and we will check if determinant of this matrix is 0, then we will say these vectors are linearly dependent. Now this is the matrix A, and if we calculate the determinant of this matrix along row, first row, so we will get 1. The minor is this cofactor is 3, 3 this plus 1, this minus 1, and 1 into 3 minus 3 for this factor, and for this we will get minus 1 plus 3. Now if you calculate this, we will get 0. It means determinant of matrix A is 0. So it means these vectors are linearly dependent. Now if we see clearly, this coordinate, suppose this is x, this is y, and this is z, this is x. If we add with y coordinate this y with 2y plus z, it means it will become 1 plus 2 minus 3, which is actually 0. Again here if we will check with this same pattern, means minus 1 plus 2 minus 1, which is also 0 for this vector. And for this vector, if we check that minus 1 minus 2 for second, minus 2 plus 3, this is also makes 0. So if you see clearly, this three vector follow this pattern, x plus 2y plus z is equal to 0. And if in coordinate system in R3, this is a plane. Now let's see it geometrically. So as we have given three vectors, 1 1 minus 3 minus 1 1 minus 1 and minus 1 minus 1 3. So these vectors are in R3. So here red line represent x-axis, green line represent y-axis, and blue line represent z-axis. And where the arrow shows, that side is a positive side of the axis, and without arrow side is shows negative side of the axis, and 0 is in between them. Now our first vector is 1 1 minus 3. So here we can see A is actually the first vector 1 1 minus 3. This is the first vector. Similarly second vector is minus 1 1 and minus 1, so which is yellow. So this is the our second vector. And third vector is minus 1 minus 1 3. So both x coordinate and y coordinate are minus 1. So and z coordinate is plus 3. So we can see here that it will be upward to the 0. Now we have seen that vectors follow a pattern which is x plus 2y plus z is equal to 0, and this is represent a plane. So if we draw this plane, that is like this, so here we can see that these 3 points lie, these 3 vectors lie in the same plane. We can here see that. So this is the mean. If 3 vectors linearly dependent, then surely they will lie in a plane.